Okay, so did you guys notice that we have two kinds of formula for determining the heat through a resistance? Here H is equals to V square by R into T, and H is equals to I square into RT. In both of the cases, we are considering the time T constant. Okay, so here in this first case, we get H is inversely proportional to R. So H is inversely proportional to R, and we get a graph like this. If we plot R in x-axis and H in y-axis, it is a hyperbolic, rectangular hyperbolic graph. Again, when we are talking about this formula, H is equals to I squared RT, here H is proportional to R. Here we get a straight line. When we plot R in x-axis and H in y-axis. So which formula to use, right? Because here resistance is inverse, here heat is inversely proportional to resistance, here heat is directly proportional to resistance. So let's make this thing clear. Here resistance R is connected with a voltage, with a battery of the voltage V, and the current flowing through the R resistance is I, and the point here is A and point here is B. Here the flow of current I is constant, as it is a series connection, right? I mean, we have nothing in parallel here, so the current flow is constant here. The point A, we got a voltage here of point A, VA, which is the voltage of the battery, and a point B here, which is the voltage of the B point. We know a voltage drop has occurred here, which is VA minus VB, so we can say that VA is greater than VB, and that's why current is flowing from A to B. Okay, so here we see that I is constant. Okay, the voltage is changing across the resistance. So here we are going to use this formula. Here the heat produced by the resistance will be proportional. Here heat produced by the resistance will be proportional relations, okay, in this case. But if we assume another case where this R is connected in parallel with another resistance, suppose this is smaller and this is that capital R, and connected across a battery of V voltage, so we are assuming it as A point and it as B point, so VA VB. We know when they are connected in parallel, the voltage across them is same, but the current flow is not same out here, right? I1 and I2, if we consider the total current of the circuit I. So here I, so here I equals to I1 plus I2. Here we see that the current is not constant, but the voltage is constant. So here we are going to use this formula. Here H will be inversely proportional to R. The relationship between H and R inversely proportionate. That means if we increase resistance here, the heat produced will be decreased. Thank you, everyone.